0.9 natin is 8 less than or equal x less than 16. And yung 1 natin is 16 less than or equal x. So, ito yung ating cumulative distribution function for this experiment. Hi everyone, this is Dixman and welcome back to my YouTube channel. For this tutorial video, we are going to discuss another topic from probability, an alternate method for describing the random variables probability distribution, the cumulative distribution function. So, without further ado, let's begin. An alternate method for describing a random variable's probability distribution is with cumulative probability such as p of x less than or equal x. So, furthermore, yung cumulative probabilities na yan can be used to find the probability mass function or yung tinatawag nga natin na sa probability distribution of discrete random variable. If f of x is equal to p of x less than or equal x for every real number, then yung f of x natin is the cumulative distribution function of the random variable x, and we have the equation for the cumulative distribution functions. For discrete random variable x, f of x satisfies the following properties. So we have three properties for cumulative distribution function. Property 1, 2, and 3. Yung property 1 and 2 natin of a cumulative distribution function simply follow from the definition. And yung property 3 natin follows from the fact that kung yung x natin ay less than or equal y, yung event natin na x less than or equal small letter x is contained in the event na x less than or equal small letter y. So, nandyan siya sa event na yun. Like a probability mass function or probability distribution, yung cumulative distribution function provides probabilities. So, there are a lot of problems where we may wish to compute the probability that the observed value of a random variable x will be less than or equal to some real number, say x. So, we should observe that the fact that the cumulative distribution function is a non-decreasing function, papataas lang siya, defined not only for the values assumed by the given random variable, but for all the real numbers. Example number 1. A computer shop carries drives with sizes 1, 2, 4, 8, or 16 gigabytes. The table gives a probability distribution of x as the amount of memory in a purchased drive. So we have the probability distribution. Find the cumulative distribution function of x. Before we proceed in finding the cumulative distribution function of this problem, additional information. So, it is often helpful to look at a probability distribution in graphic form. So, for example, we are going to graph a probability distribution. Meron tayong dalawang types of graph dito. Pwedeng line graph. And isa naman, tinatawag natin is the probability histogram. So, for example, yung line graph na tinatawag din natin in other terms as the probability mass function plot. So again, yung probability mass function, another term lang yan for the probability distribution. Kung mag-create tayo ng graph, say gagamitin natin itong probability distribution na yan. In creating a graph, so gagawin lang natin is pa ganyan. This is our x. Eto, dito natin ilalagay yung random variable values natin. So in this problem, we have 1, 2, 4, 8, and 16. Say, ito yung ating 1, 2, 4, 8, and 16 without a proper measurements. And dito naman is yung ating f of x or yung probability values natin. So this is our 0.05, 0.1, 0.35, and 0.4. So ayan, ito yung ating probabilities. Kung gagawin natin yung line graph, sulat muna natin, this is 1, 2, 4, 8, and 16. Ito naman yung 0.05, 0.10, 0.35, and 0.40. Kung gagawin natin yung line graph or yung probability mass function plot, maglagay lang tayo ng dot dito. Pwedeng broken line or straight line. Papunta dyan. Next is sa random variable value natin na 2. So, papunta doon. And sa 4 natin, we have 0.35 na probability. Sa number 8 natin, we have 0.4. Papunta doon. And for random variable value na 16, 0.10 lang siya ulit. So, we have, ayan. So, this is how you do a probability mass function plot or yung line graph natin. Another representation for probability graph is yung probability histogram. Yung probability histogram naman, so in this graph, yung rectangles are constructed so that their bases of equal width are centered at each value x and their lengths are equal to the corresponding probabilities given. So, gamitin ulit natin itong graph na ito. We will use rectangles and equal width sila. Yung center ng width na yan, ilalagay lang natin dito sa gitna. So, for example, for random variable value na 1 natin, ito yan. So, this is our first rectangle for probability histogram natin for the random variable value 1. For 2 naman, same width pa rin siya. Ayan, and for 4, for 8, and for 16, again, ito ang ating probability histograms. Yung probability graphs na yan, yung probability mass function plot or yung probability histogram is just a representation ng ating probability distribution. Going back to the cumulative distribution function, paano ba natin nahanapin yung cumulative distribution function of a random variable value ng x natin? So, let's start with determining first yung f of x natin for each of the 5 possible values ng x natin. So, we have 1, 2, 4, 8, and 16. For f of 1, again, ang cumulative distribution function, dinedenote natin siya as f of x. So, for f of 1, this is equal to p of x less than or equal 1. And say, yung p natin is equal to x equals 1. So, simply, pwede natin siyang, again, i-write as small letter p na lang, probability of 1. Ang probability of 1 natin is eto, 0.05. So, 0.05 ang ilalagay natin dito. For f of 2, we have p as x less than or equal to, or p x equals 1 or 2 nang ilalagay natin dito. And this is equal to small letter p as p of 1 plus p of 2. Since nandun tayo sa principle ng or and end, eto yan. At dahil or, pag-a-addin natin sila. So, p of 1 plus p of 2 is equal to 0.05 plus 0.10 is equal to 0.15. For the next random variable value natin, f of 4, i-write natin as p of x less than or equal 4 equals, at dahil less than or equal 4 na siya, it could be 1 or 2 or 4. So, this is p of x equals 1 or 2 or 4, and this is equal to, pag-addin natin yung tatlong probabilities ng random variable values na yan. So, probability of 1 plus probability of 2 plus probability of 4. And we have, pag-addin natin, 0.05 plus 0.10 plus 0.35 is equal to 0.5. For the next random variable value na number 8, so f of 8 is equal to p of x less than or equal 8. Ang p natin, since less than or equal 8, ang maximum natin is 8. So this is p of x is equal to 1 or 2 or 4 or 8. And again, pag-addin lang natin dahil or yung nakalagay na dyan, probability of 1 plus probability of 2 plus probability of 4 plus probability of 8. And this is equal to 0.9. Lastly, for probability of, or for the f of 16, this is p of x less than or equal 16. Again, ito lang din yung gagawin natin dyan. And ang magiging value natin for f of 16 is equal to 1. Now, for any number x or for any value of a random variable na bibigay sa atin, yung f of x natin will be equal to the value of f at the closest possible value of x to the left. For example, bibigyan tayo ng random variable value na 2.7. Dito natin lagay 2.7. And kung isa-solve natin or kung ipapahanap sa atin yung probability niyan, say f of 2.7, again, closest possible value of x to the left of x. And sulat natin, this is p of x less than or equal 2.7. Ang pinakamalapit na value dyan to the left is yung p P of x less than or equal to. Ito yun. So, meaning, the probability of the given random variable value na 2.7, if ever bibigyan tayo ng ganyan, it will be equal to 0.15. So, ito yung magiging probability niyan. Another example, kung bibigyan tayo ng random variable value na 7.999, say, f of 7.999, sulat natin as p of x less than or equal 7.999. Ang closest possible value nito to the left is dito na tayo sa f of 4. So, p of x less than or equal to 4 is equal to, ang probability niyan 0.5. Ibig sabihin, 0.5 yung magiging probability ng value for 7.999. Again, kung bibigyan lang tayo ng other random variable values, kasi ito yung ating main values for random variable sa experiment na to. We have 1, 2, 4, 8, 16. So, binigyan tayo ng 2.7. Ang naging probability niya is 0.15. Closest possible value of x to the left, yung f of 2 yun. And sa 7.9999 naman, closest possible value to the left, which is f of 4. So, ang naging value niya is 0.5. So, now, i-create na natin yung cumulative distribution function based dun sa ginawa natin kanina. And to create a cumulative distribution function, or simply CDF na lang, f of x is equal to, ganito ang magiging format niyan. So, and lalagay natin yung probabilities natin, cumulative, from 0 to 0.05 to 0.15. Ito yung mga na-solve natin kanina, to 0.5, 0.9, and 1. So, yung 0 natin, lalagay natin is x less than 1. And yung 0.05 natin is 1 less than or equal x less than 2. Yung 0.15 natin is 2 less than or equal x less than 4. Yung 0.05 natin, 4 less than or equal x less than 8. 0.9 natin is 8 less than or equal x less than 16. And yung 1 natin is 16 less than or equal x. So, ito yung ating cumulative distribution function for this experiment. For cumulative distribution function of x, meron din tayong ginagawa dito to represent. Gagamitan din natin siya ng graph. Same process from probability mass function plot or probability histogram. Dito yung ating random variable values ng x, and ito yung ating f of x. And of course, ang gagamitin na natin is itong probabilities na to. Random variable value na 1, 2, 4, 8, 16. And ito yung ating probabilities na 0.05, 0.15, 0.5, 0.9, and 1. 1, 2, 4, 8, and 16. 0.05, 0.15, 0.5, 0.9, and 1. So, para may graph natin yung CDF or yung cumulative distribution function natin, horizontal lines ang gagamitin natin. So, magsa-start tayo sa 1, 0.05, and mag-move siya hanggang dito, pero hindi exactly at 2. Kasi nga, kung check natin dito, this is, yung x natin is less than 2, hindi less than or equal to. Next, for our probability na 0.15, magsa-start tayo sa 2, ito yan, hanggang dito. Again, hindi rin siya exactly at 4. For our probability na 0.5, magsa-start siya sa 4, hanggang 8. So, not exactly hanggang 8 ulit. For the probability natin na 0.9, start siya dito, hanggang dito, hindi ulit exactly hanggang 16. And for the 1 natin, yung probability value na 1 natin, magsa-start sa dito, papunta dito. So, let's use arrow na lang. Kasi this is 16 is less than or equal x. Ganito yung graph for cumulative distribution function. And ito, yung magiging answer natin kung hahanapan tayo ng cumulative distribution function for x of a discrete random variable Yung graph natin for f of x, eto nga yun, will have a jump at every possible value of x and will be a flat between possible values, kaya ang horizontal lang ginamit natin. So, itong graph na to ay tinatawag natin as a step function. So, this is example number 1. Example number 2, a box of 850 marbles contains 50 blue marbles. 2 marbles are selected at random without replacement. Let x be the number of blue marbles in the sample. Find the cumulative distribution function of x. So, ang requirement here is yung CDF or yung cumulative distribution function of x, but of course, kailangan mo nating hanapin or i-create yung probability mass function or yung probability distribution of x. And before probability distribution, dapat makreate muna natin of course yung sample space kasi doon tayo magbabase, and after ng sample space, kailangan alam na natin yung values ngayon ng random variable x natin. For the sample space, say yung blue marble is denoted as B na lang, and yung hindi blue na marble is say N na lang. Ang magiging sample space natin dito is equal to, pwedeng ang mapili is sa 2 selections na yun, parehong wala. This is NN. So sa second selection, it could be a blue marble, not a blue marble. So sa pangalawang sample point, pwedeng mauna naman is not a blue marble and yung second selection is blue marble na, or pwedeng parehong blue marble ang mapili. So ito yung ating sample space. Next, for the random variable values ng x natin, dito is wala tayong napili na blue marble, so this is 0. Dito is 1, 1, and this is 2. Therefore, ang values ng random variable natin ay 0, 1, and 2. Dito tayo ngayon magbabase for the probability distribution function and dito sa ating sample space. So, say this is our x, and ito yung ating f of x, 0, 1, and 2. To solve for the probabilities na ilalagay natin sa probability distribution, magbe-base tayo sa sample space. For f of 0, probability ng, ito yan, ng NN. Say, probability of NN. And again, 2 selections, N and N, ibig sabihin, multiplication ulit ang gagamitin natin by the principle ng and at saka yung or natin. In selections natin, meron tayong condition na without replacement. Ang total number ng marbles natin is 850. Say, ito yung ating first selection. Wala tayong mapipili. Ang total number ng marble na hindi blue is 800. Ito yung ating first selection. And since may pangalawa pang selection, we use the multiplication rule since n and n ang ating gagawin. Dito, since without replacement, nakapili na tayo ng isang hindi marble, this is a total of 849 na lang. And dito is 799 na lang. And ang magiging value for f of 0 is equal to 0.886. Ito ang ilalagay natin dito sa ating probability distribution. For f of 1, sa f of 1 natin, we have 2 possibilities based sa ating sample space. Ito yan. It could be probability of B of N or NB. Para dito sa Bn natin and NB, gagamitin natin multiplication rule. And since meron tayong or, dahil 2 possibilities nga tayo, Bn or NB, pag-add natin yung probabilities nilang dalawa. So for Bn muna, this is probability of Bn plus probability of NB. So ayan yan. Lagay natin dito. For probability of Bn, mapipili sa first selection is blue marble. Ang total pa rin natin is 850 for the first selection. And blue marble ang unang mapipili, we have 50 times, this is our first selection. Sa second selection natin is hindi na blue marble yung mapipili. Ang total natin is nabawasan na since nakapili tayo ng isa, this is 849 na lang. Pero yung hindi blue marble, hindi pa nababawasan, this is 800 pa din. Ito yung ating probability of Bn. Next naman yung probability of NB. So this is addition. Sa probability of NB, ang unang selection natin is not a blue marble. This is 850. And this is 800 times. So nabawasan na siya ng isa dahil without replacement ito, this is 849 na lang. And dito is 50 pa din. Probability of 1 now, or f of 1 natin, is now equal to 0.1 1, 1, 1. Next, for f of 2, 0.111 ang ilalagay natin dito. For f of 2, meron lang tayong isa, probability of same blue marble. So, ilalagay natin dito, this is a total of 850. And ang unang selection is blue marble, this is 50. Times sa second selection, blue marble pa din. Nabawasan na ng isa dahil without replacement ito, this is 849. And dito is 49 na lang. F of 2 natin now is equal to 0.003. Yun ang ilalagay natin dito. For checking lang, dapat na-satisfy yung ating requirements sa probability distribution na dapat nagre-range lang sa 0 to 1 yung bawat probability natin sa random variable values. And yung pangalawang requirement, dapat pag pinag-add natin silang lahat is equal to 1. So, itong tatlo na to is equal to 1. So, tama yung ating probability distribution. And this is our probability distribution. Pero, ang requirement kasi sa atin is yung cumulative distribution functions. Let's proceed to the next page. For f of 0, so again, ang cumulative distribution function natin is f of x, yung f na malaki. For f of 0, this is p as x less than or equal 0. And this is equal to 0.886. Yung unang probability natin sa probability distribution. For f of 1, ito yan. This is p x less than or equal 1. Or again, pwede itong as p of x equals 0 or 1. We will just add. This is now equal to 0.886 plus 0.111, and this is equal to 0.997. So this is for f of 0 and this is for f of 1. For f of 2, write natin as p of x less than or equal to, and this is p of x equals 0 or 1 or 2. And again, ipag-add natin, this is 0.886 plus 0.111 plus 0.003. And this is now equal to 1. So, dapat yung final probability natin for cumulative distribution functions, since this is a cumulative, dapat 1 yung magiging last natin. And for the cumulative distribution function natin, this is our final answer, f of x is equal to, ito again ang ating format, from 0 to 0.886 to 0.997 to whole number 1. And lalagay natin dito is x less than 0. This is 0 less than or equal x less than 1. And this is 1 less than or equal x less than 2. And this is 2 less than or equal x. Ito yung ating cumulative distribution function for this experiment. For the graph naman of CDF or the cumulative distribution function natin, ito pa rin yan. These are x, the random variable values natin, which is 0, 1, and 2. And dito yung ating f of x or yung probabilities natin. Nag-start sa 0.886. Ito yan. To 0.997 to 1. Kung ipa-plot natin, magbe-base tayo dito sa ating CDF. Since yung x natin is less than 0, our first line, horizontal line, is papunta dito. For the probability 0.886, ito yung probability natin na 0. For the probability 0.886, since less than 1 yan and greater than or equal 0, magsa-start tayo dito hanggang dito. Hindi siya magsasakto sa mismong 1. So, hanggang dyan lang siya. Next, for 0.997, magsa-start tayo sa 1. Ito yung ating probability na 0.886. Ito yung 0.997 and ito yung 1. So, magsa-start yung 0.997 dito hanggang sa 2. Hindi siya exact na to kasi x is less than 2. For the last probability, yung 1 natin, magsa-start tayo dito sa 2. And since yung probability ng 1 natin is at 2 less than or equal x, mas malaki yung x sa kanya papunta dito. So ito ngayon yung magiging graph natin for the cumulative distribution function of this experiment, and this is example number 2.